This is Professor Hoffman. I want to take a couple minutes just to review the basic steps of dimensional analysis. I know you spent time working on it in class. In Canvas, you have links to the text that describes the process and gives some video links for information. But just want to talk about how to set it up. Again, dimensional analysis is an approach to calculations that you'll be facing and dealing with as a nurse. And it's just one approach that can be used. The benefits of dimensional analysis is it is a very consistent technique for solving problems that you're going to be facing. You're going to be using it in this semester and in your fundamentals classes, primarily for drug and medication calculations initially, but it also can be used when you move into IV therapy and the calculations tied into that, whether it's IV fluids or IV medications in the form of piggybacks, that type of thing. So the process will work for all of those. And how it works is we're setting up relationships based on information that we're given or that we know from the equivalency chart to be able to adjust labels and set up the information in such a way that we can solve the problem for the label that we need to move towards. So as we're looking to make use of the information, our steps are going to be starting out with the idea of identifying where do we want to end up. If we don't identify that first label, that final label that we want to move towards, which is going to be given in the question, it's going to ask how many tablets are you going to give, or how many milliliters will be given. That type of thing. The question will tell you or indicate what the final label should be. If we don't identify that initially, it's very easy to set up the relationships in such a way that we can have very good math, but our final answer will be based on improper relationships. So again, we want to start with identifying the final answer's label. And then based on that, we're going to add in what information we know or are given in the problem, or that we can pull from the equivalencies as needed. Going to set that up in a way that identifies those relationships, allows us to get rid of all labels other than that final label we want to end up with. And then all we have to do is solve the basic math involved and document our answer. So we'll look at a couple problems and talk about a couple different ways of setting it up. So in this case, the problem is an equivalency problem. It's 125 micrograms is equal to how many milligrams? Again, you'll notice here it says do not round. As you're looking at any calculation questions for this course and all your future courses, you are going to follow the basic rounding rules unless the specific question tells you not to. So if there is no comment such as this involved with the question, you are going to follow the rounding rules. So please go back and review those and the proper way of documenting our numbers as far as leading zeros or trailing zeros, that type of thing. So again, back to this problem. The question is how many milligrams? So our final response, or the answer we want to look towards, is going to be milligrams. So we put that at the very beginning. The top line is how we traditionally set it up. So it looks like a series of math equations or math relationships as in fractions. Again, we will do math towards the end, but the setup of certain numbers over other numbers are identifying known relationships. So this bottom approach may be a little more helpful visually if you want to look at that one. But going across the top one, we want to get to milligrams. The only information we're given in the problem is 125 micrograms. So we want to start that as a given. So we have 125 micrograms, and we just put that over 1 as a placeholder. That's not where we want to get to, so we know now we have to introduce an equivalency. So going back to your equivalency chart, we'll see that 1 milligram is equal to 1,000 micrograms. Milligrams is where I want to end up at, so I want to set that relationship up with the milligram on top. So I put 1 milligram on top and the 1,000 micrograms on the bottom. Now the nice thing about that is I can cancel out the micrograms since it exists on the top and the bottom. So that microgram label no longer exists in this problem. It's just canceled out. So then I'm just going to pull my numbers across the top and the bottom. So I have 1 times 100, 125. So I have 125 over 1,000. And then using calculator, pencil and paper, solve that. It's going to be 0.125. Again, the instructions say do not round. So in this case, we will not round to 0.13, which would be the normal to do with the rounding rules. But since it says do not round, we're going to leave it at the 3 places, 125, and we're going to make sure we have that leading 0. So the proper final answer is going to be 0.125. Now the bottom setup is another way of visualizing it, so it doesn't look so much like a math problem, but really focuses on the idea we're looking at relationships. So in the box to the left, we're going to again put in what is our final label? What is the question asking for? So we're going to put milligrams there. Again, we're going to start with what we know from the problem. We have that 125 micrograms. So that we're just going to place that in the top since it's a whole number, stands alone. But again, we recognize that micrograms and milligrams aren't the same thing. So we need to use an equivalency. Again, we pull in that equivalency from the equivalency chart. 1 milligram is equal to 1,000 micrograms. We can cancel out the micrograms, carry the numbers over, and then go ahead and solve it at 0.125. So again, we're starting out with recognizing where we want to begin, adding in what we know, and then adding in our equivalencies, getting to the point where we can just do the math, do the answers. For Canvas-based questions in this course and in the future, unless you're told otherwise, you will not be writing down the labels. On some paper and pencil quizzes you'll be doing in the future, your instructors may ask for the labels. But again, if it's in Canvas and it's not specified, only give the numeric answer, no labels, or else it will be marked wrong. And also remember the basic rules of having that leading 0 since it's less than 1. 0.125 would be an incorrect answer. In this case, rounding it to the 0.13 would be incorrect since the instructions specifically say do not round. So let's look at another one then. In this case, the order is for ibuprofen 400 milligrams, and the ibuprofen comes as 200 milligrams per tablet. The question is, how many tablets will the nurse give? So again, I'm going to focus on the bottom grid approach because you can follow through on the fraction type and see the setup. But I want to talk a little bit more about the grid because for some people it may be a little bit easier to follow visually. So again, in the first box, our tablets is where we want to get to. In this case, we're going to look through the problem and do we have tablets in any of the given information? And we do. It's in that ibuprofen, 200 milligrams per tablet or per 1 tablet. To end up with tablets is our final answer. That tablet information has to be on top. So we're going to flip that relationship over. So we have 1 tablet over 200 milligrams. And then we're going to go to what was ordered, in this case 400 milligrams. By having it on top, now the milligram labels can cancel out. So the only label that still exists is tablet, which is where we want to end up at. And we're going to carry the numbers across to the next column. So we have 400 over 200, and then just divide 400 by 200. Our final answer then is 2. So in this case, same problem, but worded differently. In this case, the order was to give 2 tablets of ibuprofen. It's an over-the-counter medication. It comes in a standard concentration. So what's available, and the provider recognized that when they wrote the order, is it comes as ibuprofen 200 milligrams per tablet. Same information we had before. In this case, though, we want to know how many milligrams are we going to give. So again, our first item, whether it's in the fraction format at the top or down in the grids, is milligrams. That's the label we want to get to. Now when we go to that next column or next set of relationships, we're going to flip it so that milligrams is on top. So in this case, we went to 200 milligrams per 1 tablet, or 200 milligrams over 1 tablet. And then we're going to add the order, which 2 tablets. Again, that keeps our milligrams on top and allows us to cancel out tablets as a label. We're going to take the numbers across, and so in this case we end up with 400 over 1, and we divide 400, so that's how many milligrams we're going to be giving is 400 milligrams. So again, that's why it's really important to know what label we want to end up with, so we know how to set up that relationship from the concentration, in this case the 200 milligrams per tablet. Do we want 200 milligrams over 1 tablet, or do we want 1 tablet over 200 milligrams? So again, that's why we want to start out with recognizing what our final label is going to be. Okay, in this one, we're going to have an order to give 1 gram of amoxicillin, and how it comes is as 250 milligrams of medication per 1 tablet. Question is, how many tablets will you be giving? So our beginning point is tablets. We're going to start with that because that's where we want to end as far as labels go. And then we're going to start pulling information. So we do have tablets in the given information in that concentration piece, 250 milligrams per 1 tablet. Since we want to end up with tablets, we're going to set it up as 1 tablet over 250 milligrams. Either as a fraction or in the bottom example in the table. Top row of the table, 1 tablet, bottom 250. That's our relationship. The other piece of information we're given is what was ordered, and it was ordered as 1 gram. So we're going to put that in the top of the next column. Going to recognize that grams and milligrams are not the same. So at this point, we have to add another column to bring in our equivalency. So we're going to determine how we set up that relationship. We know 1 gram from our equivalency chart is equal to 1,000 milligrams. We want to set it up so the labels, the like labels, are on opposite sides of the separating line, so we can cancel them out. So in this case, we're going to put the 1,000 milligrams on top over the 1 gram. So the milligrams from the 1,000 and the milligrams from the 250, that label cancels out. The labels from 1 gram and 1 gram cancels out. We move the numbers across, and we end up with 1,000 over 250. Do the division, and we end up with 4. So those are just some examples of how to set it up. In Canvas, I've put in a link to some practice problems. This, again, is to practice how to set up dimensional analysis if you're not familiar with it. It's not going to be a question on any of the quizzes or exams to show that you can set it up specifically in this way. But I do want to give you some problems, some practice questions, so you can get used to setting it up in the right way. So we'll go ahead and look at that real quick. So let me make this a little bit larger. So in the calculations page in Canvas, you should come down to dimensional analysis. I have the link to the text resource that describes it, and they also include a video by Sarah R.N., I believe. This video that you're watching right now will be linked here in the next line. And then you're going to have an option to go to practice questions. And again, this is just to practice setting up dimensional analysis. And it's going to be based on that table format. So when you go into that, let me go back and see what I did here. I may need to publish this real quick. I apologize for that. Let me go back into what you'll be looking at. Okay, let's go back down again to calculations page. Down to the dimensional analysis process. And when you click on the practice questions, then it's going to come up to basic entry to a quiz. Again, this is only practice questions. There are no points associated with it. It's not going to show up on the gradebook, and you can repeat this as often as you want. Initially, there are 10 examples loaded, and each time you go through this practice setup, it's going to bring up 2 of those questions. Over time, we may add more in, but the 10, I think, will give you a chance to practice doing the setups. So once you hit begin, you'll notice you have a calculator available, and it's also available in the question. And what this is going to do is it will be 2 questions, and it will come up 1 question at a time. So your instructions are to look at your provided information. We're going to do a drag and drop method from a word bank at the bottom to fill in the dimensional analysis model and then enter your answer. So we're working off of a label in this case. So the order is for prednisone 10 milligrams. That's all that the provider wrote. They would have also put in PO because this is a liquid medicine. They're just saying it's going to be my mouth. But as far as values that we need, the 10 milligrams. Then we're going to look at the label from the box and from the bottle it comes in. We're going to recognize that it's prednisone 5 milligrams per 5 milliliters. Some numbers on here. We don't care about the 120 milliliters. That's just how much medication is in a full bottle. So that really has no importance to us at this point. So we've got 10 milligrams, and we've got a relationship of 5 milligrams per 5 milliliters. So the question is, how many milliliters will we give if we're giving the 10 milligrams? So we're going to come down here and just sort of follow through our final label. Again, how many milliliters will be given? So we're going to find the milliliter label, drop it into there. And what information do we have that includes milliliters on it? We have the concentration of 5 milligrams per 5 milliliters, but we want milliliters on top. So we're going to take that 5 milliliters, and that was equivalent to 5 milligrams. And then we're going to look at the ordered dose, which was 10 milligrams. So we're going to pull that up. And again, that was given in the problem. And so when we can cancel out the milligrams, all we're left is milliliters, which is the label we want. So as we come across for our answers, you can either click on and pick from the drop down or drag from down here. Again, I don't want any labels at this point. I went to 50 over the 5. And then we're going to type in our answer. So once we put that into our calculator, do it on paper, we should end up with 10. And we're ready to move on to the next problem. So in this case, we're looking at levothyroxine. 75 micrograms is ordered. It comes as 0.025 milligrams per tablet. Question is, how many tablets? So we're going to start out with where do we want to get to. So our final label is going to be tablet. We know that 1 tablet is the same as saying 0.025 milligrams. And our order dose was 75 micrograms. So we got tablets on top where we want it, but milligrams and micrograms are not the same, so we want to bring in an equivalency. So in this case, the equivalency is going to be set up so the milligram is on top and the micrograms are on the bottom. So we know that 1 milligram is the same as saying 1,000 micrograms. So when we bring our numbers over, we're going to end up with 75. And when we do our math of 0.025 times 1,000, we should end up with 25. And I apologize that the tables are coming in. I will fix this after I do the recording. So we got 75 over 25. And when we do the math on that, we have 3. And again, it would be 3 tablets. And when we're done, we're going to submit. And you'll have a chance to go back through and see that yes, everything came out correctly. So again, once you've done that, you can go ahead and reattempt now or come back in a later point. And when you go in, you'll be asked to start a new one. And the drop downs like this do take a little bit of time to load at times, so just be patient. And you'll have 2 new problems, or it's possible that one of the ones may carry over. So again, you will again take this as many times. Right now to begin with, there are 10 example questions in there that may involve having the equivalency, may not need the equivalency, so you can just follow through with each of them. So that's just a really quick overview. And again, we invite you to go into Canvas and take those practice questions, work on those practice questions. Again, this is just to help get familiar with the process for dimensional analysis. If you're already comfortable with it, again, it's just review. If you have another method that works consistently for you and you don't think you're going to be using the dimensional analysis, you don't need to spend time. There will not be exam questions or quiz questions that are just how are you setting up the structure. They will just be asking you to solve and writing down the answer. So you will not be recreating these tables on any work that is being turned in or graded. So again, hopefully this will be helpful. And if you have any questions, just touch base with your section instructors and they can help you through the process.